Hi guys, welcome back to Advanced Algebra 2. Today we're going to be on page 226 in your workbooks. We're looking at the properties of exponents and radicals. What we're going to do is we're going to take the properties of exponents that you worked on in Algebra 1, and then we'll expand those into fractional exponents or rational exponents and radicals. So the properties listed are the ones that you may have seen in a previous course. So let's say, let's look at this product of powers. That's if you have a number, a base raised to an exponent, times another base raised to an exponent, because it's a product. We're looking for that those two things are being multiplied together. And as long as they have the same base, you can multiply those by adding the exponents. So if I want to do an example here, I could say that if I were to have x squared times x cubed, because those have the same base, I can say that's the same as x to the 2 plus 3 power, which is x to the 5th power. Quotient of powers, quotient means divide, so if I'm dividing two terms that both have the same base, I can divide those by subtracting the exponents. So if I were to divide y to the 8th by y squared, because they have the same base of y, I can say that's the same as y to the 8 minus 6, subtract those exponents, and that would be y squared. Then, power of a power, that's the one where you multiply the exponents, and that happens when you have an exponent raised to another exponent. So you'll see something like x to the 4th, that whole thing, raised to the 5th power. You'll multiply those exponents there, get x to the 20th. And then another color here, power of a product. So that kind of expands on the one right before it. It deals with if you have more than one letter, variable, or coefficient inside the parentheses. So if you had something like 2x squared y cubed, and the whole thing was raised to the 4th power, well, that 4th power exponent would distribute to all three parts. So I would have 2 to the 4th, x to the, I'm still multiplying here, 2 times 4 would be 8, and then y cubed to the 4th is y to the 12th. Then I would just go through and say, okay, well, 2 to the 4th is 16, so this is equal to 16, x to the 8th, y to the 12th power. Then negative exponent means division. A positive exponent means that x gets multiplied twice. A negative exponent means that x gets divided twice. So negative exponent is referring to division. So this is the shortcut for what you do with a negative exponent. If you see something that has a negative exponent, basically you'll take it to the other side of the fraction and make the exponent positive. Now if you don't see a fraction, you can turn it into one by writing it over 1, because anything divided by 1 is itself. So they took the a to the bottom of the fraction and made the exponent positive. So here's an example. Let's say I had 2 over x to the negative 3rd. Well, x to the negative 3rd has a negative exponent, so it would come to the numerator. It would be positive 3rd. The 2 does not have a negative exponent, so it still remains in the numerator. Then there was nothing left in the denominator once I moved this x up, so that becomes a 1, and this is 2x to the 3rd power. So this is probably how you might remember the properties of exponents in Algebra 1. But again, Algebra 1 was a while ago. Well, now, the properties of exponents do not only apply to those whole number or integer exponents, but also rational, also known as fraction exponents as well. So let's look at those. So here's example 1. We're going to see, now we have fraction exponents. We're going to apply those same properties, but now here. All right, so how can you rewrite expression? So the first thing I want to do is I want to look at this and kind of take a step back and try to identify which property is coming into play. So I see a quotient, but the only quotient is if they have the same base. Well, hope I'm not making you sick. Do these have the same base? No. Okay, so it's not that quotient one. But then we have a parentheses raised to a power, parentheses raised to a power. Those are the two that relate to this one. So parentheses to a power. All right, so that means that this 1/2 will distribute to both parts. So this is equal to 3 to the 1/2 over 32, and I'll multiply 1/2 times 2/5. 1 times 2 is 2. 5 times 2 is 10. So this is 3 to the 1/2 over 32 to the 1/5. Then I think, okay, is there a way that I can simplify this? What does this mean? Well, 1/2 means the same thing as the square root of 3 to the first power. Square 1, but usually those are understood to be there. So you don't normally see us writing this index and the exponent. So the square root of 3 to the first power. This 32 to the 1/5 power means that's the 5th root of 32. Well, we do know that the 5th root of 32 is 2, so I can simplify this to the square root of 3 over 2. So here's one way to write my answer. Another way that I could also write this, 3 to the 1/2 over 2. Either of these answers are acceptable as long as you've simplified it all the way to where you have a 2 in the bottom. Sometimes the question will prompt you to write your answer using radical form. So this would be radical form. Sometimes they'll ask you to write your answer with positive exponents. It's just kind of up to the directions in the problem. Sometimes problems don't specify which ones they prefer, and they'll take either one. But the general convention is whatever form they give you, that's usually the form that they want you to write your final answer in, unless they specify otherwise. But either way, if this were a test or a quiz and it did not specify and you entered either one of these, I would totally count either of those absolutely correct. All right, moving on. The second one here, I see, okay, I've got parentheses raised to a power. This looks like we have another power of a power scenario. So power of a power means that this 2/3 gets distributed to both parts. So I'm going to bring down the 2a to the 1/3. And then that is multiplied by a to the 2/3, b 1/2 times 2/3, 1 times 2 would be 2, 2 times 3 is 6, and 2 over 6 is the same as 1/3. Okay, so now I've got 2a to the 1/3, a to the 2/3, b to the 1/3. So now I look, are there any other rules that I could apply? I'm going to have to scroll what's underneath. Okay, where I have, see how I have the same base as a? That would be a product of powers. Same base, I can add the exponents, they're being multiplied. Let's go back to the problem. So I can add the exponents on those parts. So this would be 2a, 1/3 plus 2/3 is 1, b to the 1/3. Or just 2a to the first power, b to the 1/3 power. And then here is an extra example, I believe, where we have kind of a lot going on. You have a couple options. You can distribute, if you like, first, or you can simplify first. It really doesn't matter. You'll get the same answer whichever way you do this. However, my advice whenever you're working these, if they look super complicated, my advice would be, first of all, try to simplify the inside part first. Because usually what that does is it makes your number smaller or your exponent smaller or the number of letters. It reduces the number of variables you have. It makes it easier to look at. So I'm going to try to simplify what's inside the parentheses first. And I notice that I have an x and an x to the 1/2. So I can combine these by subtracting their exponents. Now in the numerator there's not an exponent written, but if it's not written it's understood to be 1. So inside those parentheses, I can think of it as 1, x to the 1 minus 1/2 times y cubed, then all raised to the 2/3 power. So this would be x to the negative 1/2 y cubed. See, that's a little bit easier to look at, all raised to the 2/3 power. So then I can do the power to a power where you multiply those exponents together. So I have x to the negative, let's see, negative 1 times 2 would be negative 2 over 6. Negative 2 over 6 is negative 1/3. Y, multiply 3 times 2 over 3, you get 2. So it looks simple, but most of your problems will say, over here, write your answers with positive exponents. So that means you can't have this negative exponent right there. So I'm going to say, okay, well, I need to send it to the other side of the fraction. I don't see a fraction right now, so I'm going to make one by putting this whole thing over 1. So then the term that has the negative exponent, this right here, this is going to go to the denominator. So I'll have y squared over x to the positive 1/3.